Good evening, ma'am.
Good evening, Kirtana. Well, what we were doing in the last class?
Internal.
This we were doing, right? Have you done the revision of this part? Have you done the revision, Kirtana?
Yes, ma'am. Yes, ma'am.
All right. Let me check that where we have left. We were doing the concept of internal energy, and we were doing that how we change the internal energy, right?
Yes, ma'am.
Okay. Now we will discuss today that how to change the internal energy of a particular system, basically, or what are the ways in which we can change the internal energy, right? We have already discussed that we can change the internal energy by matter, heat, or work, right? So first we will discuss about when we have adiabatic system, basically. So when we have adiabatic system, so as you know that adiabatic system do not allow the transfer of energy and heat, right? If we
Yes,
want
ma'am.
to change the internal energy of adiabatic system, so we can't do it with the change in energy or heat. We can only, what we can do is, it is the only work that by doing the work, we can change the internal energy, right?
Yes, ma'am.
So we have only work. Work can be your mechanical work. It can be your mechanical work or it can be your electrical work. Is it clear?
Yes, ma'am.
When we do a work, basically, the only thing that matters is that how we have do the work over the system. Like if you have to move from A point to B point, okay? So work is basically what? Force into displacement. One work is that you are moving to B in this path. Second is that you are moving like this one, right? Right? In
Yes,
both
ma'am.
cases, you have displacement A to B only. Either you are going this way, you are going this way because displacement is the shortest path, right? It means that it is only the final position or the state that matters, not the way that we are doing the work. Clear? It means change in work, basically, change in state of system is same irrespective of the type of work. Either we are doing mechanical work or we are doing electrical work. The only thing that matters is that we are doing the work. It can be any work.
Yes, ma'am.
Is it clear? So we can say the delta U depends on adiabatic work. Delta U is what? It is the change in internal energy, right?
Ma'am.
Can we say this thing?
Yes, ma'am.
Or we can say that work adiabatic, we can write it like this. So when we do work on the system, when we do work on the system, then it is positive. When work is done by the system, it will be negative. Is it clear?
Ma'am.
Okay. What work we are talking about? We are working about work adiabatic over here. Clear? One thing is that we have changed the internal energy with work when we are doing the adiabatic work. But now we are not doing the adiabatic work. We are taking the isolated system when we allow the transfer of heat and work. So by work, we know that how the impact of work takes place on the change in the internal energy. Now, next is that how heat changes my internal energy. So when heat passes into the system, my heat will be positive. Clear? Heat comes out system, it will be negative. Can I say this thing?
Yes, ma'am.
It means my delta U depends on heat also, right?
Yes, ma'am.
Q heat is what basically? Kirtana, just wait a minute. Yeah. Is it clear, Kirtana? That the heat that we are talking is basically represented with Q. So when it is positive, we can say my Q is positive. When it is negative, I can say that my Q is negative. Clear?
Yes, ma'am.
Q positive means, lose my cursor. Yeah. Q positive means my heat is transferred from surrounding to the system because heat is getting into the system, right? When it is negative means my heat is transferring from system to surrounding. Can I say this thing? Can I say this thing, Kirtana? As my heat comes into the system, means heat is coming from the surrounding to the system, so my Q is positive. As my heat comes out of the system, means heat coming out of the system means it is moving to the surrounding. That's why I have taken it negative, right?
Yes, ma'am.
So I can say that my delta U depends on heat as well as on work. Can I say this thing? Are you understanding what I said?
Yes, ma'am.
So delta U is equal to Q plus W. This is my first law of thermodynamics. Clear?
Yes, ma'am.
Or I can say that my energy of a system is isolated or constant basically. My energy of the system remains the same always. It remains constant. So energy of isolated, why? Because it is only the isolated system where we can change the heat and work both.
Yes, ma'am.
Okay. This chapter we will do just a short part on the daily basis, because if we do the class for the like na, if we continue it for longer one, then it will get सब पक जाएगा, वो mix up हो जाएगा सब कुछ, because everything is na confusing in this chapter. So we will do small parts on daily basis. ठीक है? तो हमारा जो आइसोलेटेड सिस्टम है, तो हम क्या बोल सकते हैं? फॉर आइसोलेटेड सिस्टम वी कैन चेंज द इंटरनल एनर्जी बाय चेंजिंग द हीट एंड बाय चेंजिंग द वर्क, बट माय टोटल एनर्जी विल रिमेन कांस्टेंट, आइदर वी आर चेंजिंग द हीट और वी आर चेंजिंग माय वर्क. Clear?
Yes, ma'am.
As we know, my delta u means energy. Energy is a state function. How state function? The example that I gave you, that if you have 2 points A and B, you have to move from this point to this point, right? So if you move this one, less energy will be used. If we move you like this one, then your more energy will be used. है ना?
Yes, ma'am.
So that is why my delta U is a state function. Q is heat. It doesn't depend that how you are providing the heat. It only depends on the final and initial temperature. In the same way, my work is also a path function. It depends on the path only. Clear?
Yes, ma'am.
Next is that how the units of internal energy changes if energy is released from the system. If energy is released, then we can say my delta U is negative. If energy is absorbed, then my delta U is positive, right? ऐसे याद करो, suppose you have a wallet. If something you are adding into the wallet means something is getting into it,
Yes, ma'am.
then it will be positive. अगर आपके वॉलेट से कोई चीज बाहर हो रही है, जा रही है, देन इट विल बी नेगेटिव फॉर यू, कि मेरे वॉलेट से कुछ बाहर जा रहा है,
Yes, ma'am.
देन इट इज नेगेटिव. इन द सेम वे अगर हम वर्क कर रहे हैं सिस्टम पे, यानी हमने वर्क अंदर दिया, इट इज पॉजिटिव. वर्क अगर हमसे करवाया जा रहा है, मतलब वॉलेट से बाहर जा रहा है, देन इट इज नेगेटिव. हीट अगर हमारे सिस्टम के अंदर जा रही है, तो इज इट पॉजिटिव. हीट हमारे सिस्टम से बाहर जा रही है, देन इट इज नेगेटिव. In the same way, if energy is releasing, then it is negative. If energy is absorbing, then it is positive. Clear?
No.
Any doubt in that one? Any doubt, Kirtna?
No, ma'am.
Okay, just wait. Now, the next thing that we have to do is how to change the internal energy of a system if we do some work basically. So now we do like, we will change the internal energy by pressure volume work. We will do the pressure volume work on our system and we will change the internal energy on my system. Clear? How to do it basically? Suppose we have a piston like this. This is my piston. Okay? Like this one. Clear? This is my initial phase. Like I started applying pressure external over here. When I applied the pressure to my piston, this piston will move over here, right? Getting? Means it has traveled some distance, that is this L. Before that it is here. But when I applied the pressure, the piston moves to this point. That changes L. Can I say this thing, Kirtna?
Yes, ma'am.
So I can say that there is a volume change in my system that will be delta V. How much it will be? Length and area. This is my volume.
Yes, ma'am.
So I can write it as length into area, or we can say V final minus V initial, right?
Yes, ma'am.
So this is my delta V. I have applied the pressure. So pressure is what? Force divided by area,
Yes, ma'am.
right? So force is what? P into area, and P what we have applied? P external we have applied multiplied by area. This is the force,
Yes, ma'am.
right? So now work done. How much we have done the work over the system is work done on the system when we move the piston. Means we are doing the work now if we are moving the piston.
Yes, ma'am.
Okay. So work is what? Force into displacement. Displacement is what? It is L, right?
Yes, ma'am.
Now force is what? P external into area. That we have already find out. This is right. And area into length is what? It is delta V. So we can say P external delta V,
Yes,
correct?
ma'am.
As my volume is decreasing, so my delta V will be negative, right?
Yes, ma'am. Yes,
I
ma'am.
know that if my work is done on the system, my W will be positive. It should be positive now.
Yes, ma'am.
So to make it positive, I know my delta V is negative. I can write it like this one, putting a minus sign over here. Then my W will be positive.
Yes, ma'am.
So this is a case when we do the compression basically. हमने यहाँ पे क्या किया? We compressed our system, right?
Yes, ma'am.
When we expand the system basically, in that case my volume will increase. When I expand the system, my volume will increase, right? So this
Yes, ma'am.
volume will be positive now.
Yes, ma'am.
My work will come out to be negative. This delta V is positive, so my work will be positive, negative.
Yes, ma'am.
If my work is negative means now the system is doing the work to get expanded. If work is done by the system, then it will be negative.
Yes, ma'am.
Clear? Is the concept is clear? This
Yes,
is
ma'am.
basically the one step process. Like either we have compressed or we have expanded. But if we do, we are applying small pressures. Like if we are doing it in multiple steps, like first we apply a little bit pressure, then we applied a little bit pressure. So what we do in this case, we put a summation over there,
Yes, ma'am.
or we can simply do integration. P external delta V from V initial to V final. Can we do this thing?
Yes, ma'am.
So this is the expression for W. When we have one step process, we use this formula. When we have multiple steps, we use this formula for the work. Is it clear? Is it clear, Kirtna?
Yes, ma'am.
Just go through this part. Today we will do only that part because if we continue it, then everything will be messed up. Because it's a thermodynamics and each and every topic requires time. So just reread it that what we have discussed. If you found doubt, then you can ask me.
Okay,
Go
ma'am.
read the concept in deep only. No read it's not, it should not be like that. Just read you just read it like that what the ma'am has written over here. Just go through the concept also.
Okay, ma'am. Ma'am, can you scroll it?
Yeah.
Ma'am, can you scroll it? Ma'am, can you scroll it?
Yeah. Just go through the concept also, Kirtana. Otherwise, it will be messed up.
Ma'am, can you scroll it? Ma'am, can you scroll it? Done, ma'am.
Then, so any doubt in this one, Kirtana?
No, ma'am.
Okay, we will do this part only. New part we will start from tomorrow. And try to do it again and again because it is the difficult one. And in thermodynamics, you require like continuous revision. Otherwise, it will be messed up. Okay?
Yes, ma'am.
Yeah.